I was 5 years old, I remember my uncle coming back from the Air Force. He was in maintenance of jet aircraft, and later retired a few years ago with enough hash marks on his arms that most Air Force personnel had to respect it. Of course, being in the Air Force got me interested in jets. I wanted to be a fighter pilot and asked my uncle what it would take for someone who had glasses to be a fighter pilot. He lied and told me that I had to be smarter than everyone else. I was too young to know any better, and when he told me that he worked in avionics, aircraft electronics, I was inspired to learn the math behind the jets and electronics for their instruments. I then saw Neil Armstrong make his first step on the moon. Of course, TV shows and movies then influenced me from there. Star Trek with Spock solving high physics mathematical equations to save the Enterprise.
Level. Raise antimatter 840 degrees.
That'll take 4 minutes.
Having the time, we'll have to risk it. Bridge, we're ready. Engage.
The $6 Million Man who was injured astronaut, and they gave him bionic biological electronic limbs to replace his damaged ones, giving him super strength. Lost in Space with the B-9 robot.
I cannot accept that course of action. I cannot
Star Wars with its droids.
Hello, I am C-3PO. R2-D2, a pleasure to meet you.
And the Terminator movie series. Is it any wonder then that I ended up at Purdue University and received a BS in mechanical technology, majoring in computer-aided manufacturing and robotics engineering? Now wait, I know what you're thinking, but I wasn't working on androids like C-3PO from Star Wars, Data from Star Trek, or the T-1000 or the T-X from the Terminator movie series, nor cyborgs like the T-100, which was Arnold Schwarzenegger's Terminator and the $6 Million Man, or robots like the R2-D2 or B-9 from Lost in Space. I was working with an articulated industrial robots. They are 6-axis robots and are actually just mechanical arms. Here are the 6 axes of the robots. You see the first 2 are for the movement of the shoulder, the third, the elbow, the fourth is the twisting of the lower arm, the fifth is the bending of the wrist, and the sixth is the movement of the tools or fingers. Okay, so you have this robot arm, and you want to make sure that nothing is in its way when it is moving. You can calculate this easily enough by using the law of cosines, which is, of course, the length of a squared is equal to the length of b squared plus the length of c squared minus 2 times the length of b times the length of c times the cosine of the angle A, which is opposite of the length of A that we're trying to figure out. Okay, so let's assume that the first length is 6 feet long and the second length is 5 feet long, and we have a 60-degree angle. This would give us an A of 5.57 feet. We know this by resolving using the law of cosines. Now, you can do this in other angles, in other positions, and calculate the further reach of the arm of the robot.